Hello and welcome to Power Usage Analytics, made possible by Microsoft Power BI for Office 365. In this session, we're going to take a look at enabling conservation through big data insights for a North Texas electric retail provider. In recent years, North America has benefited enormously from the great strides made in energy exploration and production. In a few short years, the United States has gone from a net energy importer to an energy exporter. We are experiencing an energy revival, and the future is bright. Understanding that our natural resources may be abundant, we also realize that they are limited, and to be responsible patrons we must conserve. Smart meters provide a unique technology to allow us to monitor and conserve energy. Consumers and energy utility providers can play an equal part to ensure that future generations of Americans get to share this abundance of energy. Smart meters connect homes and businesses to the electric grid in a way never previously seen. A two-way communication network helps manage demand on the grid by providing consumers with better insights into energy usage to make more informed choices about their energy consumption, while allowing utility providers with the ability to increase service and reliability through real-time monitoring. Smart meter data is transmitted by radio frequency from the property to the utility provider, where it is loaded into a meter data management database. Given that each home or business can generate large volumes of usage data, the challenge was how to manage this volume of data generated and be able to create usable data insights. Over 3 billion data records, that is billion with a B, were loaded into a SQL Azure database, and using Power Pivot, Power Query, and Power View, unique insights were generated and shared using Office 365 and Power BI. Let's take a look at how this was accomplished. So let's open Excel. We click on the Manage button of the Power Pivot tab. And firstly, we're going to make a connection to our SQL Azure database. By clicking Next, we can take a look at all the tables within our database, but in this case, we're just going to write a query to pull in account data. Let's pull in some additional data. Here we're going to take in some temperatures, weather station data that has temperatures recorded for days. Repeating this process, we can pull in all the additional tables that we care about. Next, we're going to take daily usage table and we're going to enhance it. For each property, we're going to pull in the temperature at the closest weather station for each property. We'll use this information later on to correlate the usage by temperature. You can see here where we've used the lookup value. And next we're going to get the minimum average temperature for each property, and we'll repeat the same for the maximum temp range. Also, we have the usage, power usage for each house, and we're going to do a sum on this so that we can slice it later on by property details and by date. Being able to slice this data, we need to establish some relationships between these tables. I'm making a connection to the date dimension, but I've also made other connections. Next, we're going to go and create a pivot table, just so that we can browse through some of this data. Selecting a new worksheet, click OK. And on the right, we can select pivot tables that we care about. Each meter is assigned to a substation. And we can see the daily usage for each substation. Next, we're going to select the substations, the cities, and the subdivisions. And across time, we can see average usage. Next, we're going to take a look at Power View and Power BI for Office 365. Click on the Insert ribbon, followed by selecting Power View. What we're going to look at is creating energy usage by home age. We'll select daily usage, the average usage. I'm going to look at that across months. So here we have a table that shows average daily usage across each month. I'm going to change that to a line chart. Since we're really interested in looking at this across different types of properties, I'm going to go down here to the property dimension table. I'm going to select square foot range. It shows quite a lot of different usages. We're going to filter that down. Let's take a look at homes between 2,000 and 2,500 square feet. Next, we're going to look at the year built range. We're also going to filter that down. We're going to look at older homes built between 1981 and 1990, and newer homes built since 2011. It's apparent from this report that newer homes obviously use less energy than older homes, but it enables the power provider to be able to identify subdivisions with older homes, maybe kind of reach out to those consumers and offer conservation tips while offering better rate plans for homeowners of newer homes. Here we see the energy usage by home age report after some additional formatting has been applied. In this report, we see the average usage by subdivision. I've filtered it down so that it's showing subdivisions with homes built between 1981 and 1990, allowing the utility provider with the ability to identify those subdivisions. This report shows usage for houses with swimming pools. As expected, those homes with swimming pools use more energy than those without. In early December 2013, North Texas experienced an extreme weather event. The top chart shows average usage leading up to this time. The bottom chart shows as temperature dropped, usage during the event increased. Using Power BI, we can share our Excel document containing our Power Pivot data model and Power View reports. In addition, you get full report interactivity. Next, let's take a look at how we can visualize the same extreme weather event using Power Map for Excel 2013. To get started, we will need to create a data set to use as our data source for our Power Map. Here we see the results set from a simple query I've executed against my database. The columns returned include the date, the latitude and longitude of the smart meter, the average temperature for the closest weather station, followed by the average usage on that smart meter on that date. To launch Power Map, click the Map option, followed by Launch Power Map. Here we show a map of North Texas. I've created two layers. Let's take a look at both layers. The purpose of layer 1 is to display the average usage across time. I've chosen the heat map type. Let's switch it on and see what it looks like. You can see the intensity of color signify the increasing usage of power. Let's take a look at layer 2. Layer 2 will display the average temperature across the same time period. For the type, I've displayed column. Let's switch that on. If I zoom in, we can get a better picture. Clicking on any one of the blue bars displays the average temperature at this point. Down at the bottom of the screen, you can see this play button. When we click play, the Power Map will cycle through the state, displaying average temperature as it changed, plus the average usage power. What we're looking at is to see the significant event that occurred in early December. You should see the bars dip down as temperature dropped, while the intensity of the heat map colors increased significantly as power usage increased. It's around December 5th what happened. And there you have how Power Map can help visualize the impact that weather has on power usage. And that is how Power BI for Office 365 can be used to provide better insights into energy usage.